Hey everyone, so let's solve today's LeetCode POTD, a minimum penalty for a shop. So the problem is pretty simple. Let's go through the problem statement. So we are given the customer visit log of a shop, which are represented by a zero index string customers, which consists of only characters n and y. Now, if the ith character is y, it means that the customer comes at this particular ith hour, and if it is n, that means no customer comes at ith hour. Now, if we close the shop at suppose jth hour, this j can go from 0 to n, then the penalty is calculated as follows. So if we are closing the shop at jth hour, then for every hour when the shop is open and no customer comes, so if we are closing at jth hour, so for all the hours from 0 to j minus 1, all those times where the shop is means in this time period the shop is open. So if the means shop is open and no customers come, the penalty increases by 1. So what will be the case of no customer comes? That means there are n present. So means the number of times n are present in the segment 0 to j minus 1, that many times the penalty increases by 1. Okay, so it will be simply the number of n's in 0 to j minus 1. And for every hour when the shop is closed, it will be closed from j till n, suppose. So j till means n minus 1 currently. So when the shop is closed and customers come, so customers come, it means for this period the shop is closed. So if the customers are coming, that means the value is y. So the number of values means number of y's on in this period will be representing this penalty. The shop is closed and the customers come. So in this case, what will be the penalty will be increasing by the number of y's. Okay, because for each y it increases by 1. Now we need to return the earliest hour at which the shop must be closed to incur a minimum penalty. So we need to find out this minimum j that we can get, such that the penalty that we have encountered, that is the number of n's on the left plus the number of y's on in this segment, is means minimum. Okay, and note that if a shop closes at the jth hour, it means that the shop is closed at the hour j. Okay, and we are given that the length of customers can go up to 1e5 and customers only consist of characters y and n. So what do we want? We have suppose the customers at y and y. So if we close at this hour, then it will be simply the number of n's on the left, which is simply 0, and number of y's from this segment to it is 3. So if we close at 0th hour, the penalty will be 3. Now if we close at this hour, then the number of n's on the left is simply 0, number of y's on this right is 2. So in this case the penalty will be 2. Now if we close at this hour, the number of n's on the left is again still 0, and number of y's on the right is 1. So penalty will be 1. Now if we close at this hour, then the number of n's on the left is 1, and the number of y's in this segment is also 1. So 1 plus 1, it will be penalty 2. And similarly, if we close at the nth hour, that means it will be simply the number of n's that we have encountered on the left, which is 1, since the penalty will be 1. So we see like the minimum penalty that we have is 1, and it occurs the most earlier at point second hour. So we can close at second hour and we'll be getting the minimum penalty, since the output here is simply 2. Okay, so means we can follow the simple approach that we discussed. What do we want? If we are at a particular means, we'll move j initially from 0 to n minus 1. Now what do we want? For this j, we can simply move I from 0 to j minus 1 and count n's. Okay, and then move I from j to n minus 1 and count y's. And simply the current penalty will be the current penalty that we'll have, it will be simply the count of n's plus this count of y's. Okay, and hence we can maintain a minimum penalty variable and initialize it with a very large value, as well as the earliest hour value vary, okay, which will be changing based on this minimum. So if the current penalty that we have, current penalty is less than this minimum penalty, we can update this earliest, means we can update this minimum with current, as well as we will be updating this earliest hour that we have, earliest hour of closing, with the current penalty, which is simply j. Okay, so we can follow this approach, and since we know since we'll need to iterate for each j from 0 to n minus 1, as well as we can close at the nth hour as well. So closing at the nth hour, what do you want? We just simply want the count of n's on the left. So we can, in the end, we can simply see the count of n's and account that as well in the current penalty. Okay, so do that calculation separately as well. So you see this will be taking an order of n, and both of these calculations will be taking an overall order of n, and which will be like the overall complexity will be order of n square, which will give us TLE because n can go up to 125 here. So obviously we need to calculate these count n's as well as count y's means efficiently in constant time, or like means the expected approach might be n log n or order of n. So how do we do it? We can say, no, like we are moving this j from start to forward. So this count n's we can simply maintain by creating a prefix count, and as we move forward we will simply keep increasing its count. So we'll be able to know the current count that we have. And what about this count y? So what do we want? We want the count from j till n minus 1. So as soon as we move forward, we want to means if we have already calculated the total number of y's in this segment, as soon as we move forward, we can simply decrease the count of y as soon as we encounter y's. So if we keep decreasing it, then this segment will be storing the count of y's in this segment. Okay, because we have reduced the y's which have occurred so far, and we already had the total number of y's. Okay, so following this approach, we will be able to find the count of n's as well as the count of y's, and then we'll be able to do both of these calculations. Everything else will remain the same. We just want to find these values in like optimized time. So how we'll do it? We'll simply initialize. We'll first find the count of y's. Okay, so initialize with 0. We'll find out the count of y's by iterating through the entire string. Okay, so count y's is calculated. Now we simply initialize the current nose as 0. Now as we move this j from 0 to n minus 1, currently what do we have? We'll have some nose as well as some y. Okay, so current penalty will be simply what? The count nose plus count y's. Count yes. Okay, now if means we'll simply see if current penalty is less than minimum penalty, we will update. And now if this customer of g means if this s of j is equals to y, what do we want? We want to decrease the count yes count, so that for the next j the count of yes stores from j till n minus 1. So we'll simply decrease this count yes that we have. Okay, or else if this is no, then we can simply increase the count no, so that we have the increased number of count no's on the left. So we can simply increase the count no's, and we can simply check like whether if the current penalty is less than minimum penalty, we'll update our minimum as well as the earliest hour. And in the end, we want to see what if we close at the nth hour. So for closing at the nth hour, the penalty will be simply the number of no's on the left. So it will be penalty will be simply number of no's. So if this the count no's that we have is less than minimum penalty that we have got, minimum penalty, so we can simply return nth hour, because closing at nth hour is most optimal. Else we'll return the earliest hour that we have calculated. Earliest hour. Okay, so in this manner we'll be able to solve this problem in without using any space for computing the keeping track of the counts, as well as we'll be able to do it in order of n. So let's see the implementation of this like optimal approach. And so we'll simply find out the count s. We iterate through the entire string, find the count of s. Now we have count no as 0. We have initialized the minimum penalty with a very large value as well as the earliest hour. Now we iterate through each I from 0 to n minus 1. The current penalty is simply count no plus count yes. If the current penalty is less than min penalty, we update the min penalty as well as the earliest hour. And now we update the count. So if it is no, then we'll simply update the count no. Else if it is yes, then we decrease the count yes. And we also need to check if we are closing at the nth hour, then the number of penalty will be simply the count of no's on the left. So it should be, if this count no is less than min penalty, that means closing at nth hour is optimal. So we'll simply return n. Else we'll simply return this earliest hour. So we'll be done by using this simple approach, and this will be like the order of n approach, which is like the most optimal approach here. So let's try to submit this approach here and see how much time it takes to run. This is the same code that we discussed, and it runs in 4ms and beats most of the solutions. So this is like the most optimal. So I hope you were able to understand. This was pretty on the easier side only. So I hope you were able to follow along with the approach. And if you did, make sure to like as well as subscribe. And if you yet have any doubts remaining, make sure to comment down. I will be happy to respond. Thank you so much for watching.